So let's talk about lights now. You know, we have a light already, which is our distant light here. Well, really, it's a sunlight. We changed it in the thing. To reiterate, there's an idea of area lights in general. So this is a sunlight, but we could have changed it to a grid. This is also an area in a sense. Let's ignore what's going on down there. It's any kind of light that has a surface. It is an entire square. Historically, a lot of lights were just like point lights. It's not really a sphere. It was literally just one point. So when we would do lighting calculations, you know, the ray would come out from the camera, which is over here. It would shoot out into the scene. And then the lighting calculation would simply say, okay, and I'm definitely going up to here, or at least I'm checking to see what the shadow is, right to here. And it's easy. It's just one point. It's very fast, but it's not realistic. Most lights are not an infinitely small point in space. So we've seen a few of these kinds of demos at this point, but just to be clear, so now we only have pretty much just one secondary ray going back because we don't need to sample that larger light in multiple places. We're going to get these hard shadows like this. There's not ever going to be like an average of these rays, of these secondary rays. It's either going to be blocked or it's not. So point lights are very fast, but not realistic. Commonly used in video games because they are very fast. A disc, though, however, has size. You can change the size. I think you can change it actually on the area light options itself, like so. Make it bigger and smaller. What effectively happens, the bigger the area is the softer the shadows get. The smaller it gets, the more like a point light it becomes. Essentially, the reason why the shadows get softer is, you know, and that's the beauty of these area lights. They're wide, and therefore there's greater opportunity to get this averaging, the averaging that leads to soft shadows. See how there's that nice gradation here on each side because of the averaging that's going on. There's a lot of opportunity for rays to, like in a situation like this, about half of them are being blocked. So they're getting averaged together, the dark rays and the light rays. You know, I also have it in here. These don't get light just because they have to travel so far through this fog to get back to the light. So they end up getting occluded just by their own density. Never mind these like geometry things out here like this. But what I want to be clear is, you know, an area light can basically become a point light if it's small enough. You know, there's just not that much opportunity for that averaging to occur. So we end up with sharp shadows, like so. And the opposite is, of course, true as well, where if we were to come back, make the area light crazy big, if it's too big, now it'll pretty much always have a chance. There's never really any spot on this that's completely in the dark. It gets maybe dimmer over here, but as you can see, even right behind this thing, we're still getting, it can still see the light a little bit. So we get something like that. So that's what happens. The larger the area light is, the more opportunities it has to actually be blocked and the more opportunities it has to actually receive the light. Whereas again, the smaller it gets, it will either hit it or not. And there you go. So you get a sharper shadow. So all that is to say that with the sunlight, which is fairly commonly used, the sunlight has area, but it's also infinitely far away. So the samples that sample it have to be parallel to the sun. So you get a nice looking soft shadow that doesn't feel like it's being cast by something nearby. If this was a point light, especially if the point light was, you know, down here near this, you know, this is going to cast shadows going this direction, and it's going to cast shadows going this direction. So it'll look like there's literally a light bulb in the scene casting like a perspective all over the place. Whereas if it's a sun, it's not actually here. It's this orientation, but it's not actually here. It's just parallel lighting going up out into space, but it still has a soft edge. So sunlights are used. We've been using them already to do this, but I'm gonna stop using it. And in fact, I'm gonna turn back on our ground plane. Just put the star back in here. Let that go. And that's the last time we're going to see our sunlight being used. Nothing wrong with it, just not going to use it this time. Cool. So I'll do a snapshot again here. Very good. Let us continue with some other lights.